Now we are going to discuss about the topic electric dipole. An electric dipole is nothing but two equal and opposite charges separated by a very small distance, let us say it is t, and the product of charge and the spacing, that is the distance, is called as dipole moment. In equation it can be written as m is equal to qd, where m is the magnetic dipole and q is the charge and d is the distance between them. Now let us calculate the electric potential that is produced due to a dipole. Now let us consider a dipole, that is q and minus q. It is separated by a distance d. Now this is an electric dipole. Now consider any point P at a distance r from the center, and it is at a distance of r1 from q, and it is a distance of r2 from minus q, and the center is exactly in between, that is the distance between q and the center is d by 2, and here it is d by 2. Now let us see a potential at P due to the positive charge q, that we can write as V1 is equal to q divided by 4 pi epsilon r1, where r1 is the distance of the charge and the point P. Now due to the charge minus q, the electric potential can be written as V2 is equal to minus q divided by 4 pi epsilon r2. Now the resultant potential is the addition of potential of V1 and V2, so we can write V is equal to V1 plus V2. So now we get V1 is equal to q by 4 pi epsilon r1 plus V2 is minus q by 4 pi epsilon r2. Now we take the q by 4 pi epsilon as constant outside, so we get V is equal to q divided by 4 pi epsilon into 1 by r1 minus 1 by r2. This is the minus of the charge q. Now we have to find the value of r1 and r2 from the diagram. Now we have to find the value of r1 and r2. Now let us consider this triangle. The value of this length can be written as the total length r minus the small length r1. That is, when we take and write as outside, we get the 90 degree, we write this side as r minus r1, the angle theta is here, and this side is d by 2, that can be written as hypotenuse. Now on finding the value of cos theta, we write the value as r minus r1 by d by 2. That implies d by 2 cos theta is equal to r minus r1. That implies r1 is equal to r minus d by 2 cos theta. Similarly, for r2, we can write it as r plus d by 2 cos theta, where we are considering this triangle, and this side can be written as r2 minus r. On substituting the value of r1 and r2 in the above equation, we get V is equal to q by 4 pi epsilon into 1 by r1 is r minus d by 2 cos theta minus r2 is 1 by r plus d by d plus 2 cos theta. On multiplying, we get it as q by 4 pi epsilon into r plus d by 2 cos theta minus r minus or minus is plus d by 2 cos theta divided by r minus 2 cos theta into r plus d by 2 cos theta. Now here r and r get cancelled. Now this is in the form of a minus b into a plus b, that is equal to a square minus b square. So we can write it as q by 4 pi epsilon into, now d by 2 cos theta plus d by 2 cos theta can be written as d cos theta divided by r square minus d by 2 cos theta the whole square. Now here we take a condition that d by 2 is very much smaller than r square, that is r square is so greater that it is the d2 is considered to be a minute value. So we ignore this term and we write it as q by 4 pi epsilon into d cos theta by r square. Now we know, as we learned already, that m, the electric dipole, is equal to q into d. So we can write the potential V is equal to m cos theta divided by 4 pi epsilon r square. Now this is the electric potential due to a dipole. From this equation we can find that the electric potential V is directly proportional to the dipole moment and it's inversely proportional to the square of distance between them.